Hello students, welcome to EPG Pathshala. I am Dr. Dinesh Kalyanasundaram from Indian Institute of Technology, Delhi. Today we are going to discuss about a module on trigonometry. To understand the importance and relationship between angles and lengths in any regular structure is the focus of today's study. A triangle is the smallest of any regular structure. To extend the same concept and calculate angles and lengths in different geometrical entities by constructing an imaginary triangles. And then we will focus on to understand the various applications of trigonometric functions. So the parts how we are going to see is what is trigonometry, then when to use it, what is the physical significance, followed by some solved examples. Trigonometry, what it is. Trigonometry deals with right angle triangles, the ratio and relationship between the triangle sides and angles. Trigonometry can be decomposed into the words trigno and metry. The first part of the word is from Greek trigon, meaning triangle. The second part of trigonometry is from Greek metron, that means a measure. Hipparchus is considered the founder of trigonometry. He was born in Nicosia, Bithynia, which is now in Turkey. Earlier study of triangles can be traced to 2nd millennium BC in Egyptian mathematics and Babylonian mathematics. The development of modern trigonometry shifted beginning with the 17th century mathematics, Isaac Newton and James Stirling, and reaching its modern form with Euler. In Indian astronomy, the study of trigonometric functions flowered in the Gupta period, especially during the Aryabhata, 6th century. Pythagorean theorem. It states that the square of the hypotenuse, that is the side opposite to the right angle, is equal to the sum of squares of the other two sides. So let us see an example where we can assume a triangle with two sides 3 and 4. To form a right angle, the third side has to be 5. So let us add the squares 3 squared, 4 squared and 5 squared. We can see that the sum of the two squares of the side 3 squared plus 4 squared will be equal to 25, and 25 is also the same as 5 squared, which is the hypotenuse squared. So the right side of the page shows 3 squares A, B and C, and in the center is a right angle triangle. So the squares A, B have been formed by having one of the sides of the triangle as a member of the square. So A squared will be the area formed of the square if one of the side of the using one of the side of the triangle. Similarly, B squared is a square formed by taking one of the side of the triangle as its side. Then the sum of the areas of A and B will be the same numerically or in scalar product as the C squared. Trigonometric identities. The first trigonometric identity is sine squared of theta and cos squared of theta is equal to 1. How do we prove that? The proof is as follows. C squared is equal to A squared plus B squared. That is what we know from the Pythagorean theorem. Dividing both sides by C squared, we get 1 is equal to A squared by C squared plus B squared plus C squared. But we already know A by C is sine theta and B by C is cos theta. Therefore, we can write 1 as sum of sine squared of theta plus cos squared of theta, and please remember that theta can be any random or any angle theta. It need not be lesser than 90, it can be more than 90, it can be anything. But it is going to be for the same angle theta, the rule of 1 will always be the sum when you square the sine and the cos of the angle. The second important identity is secant squared theta minus tan squared theta is equal to 1. Proof. As we know that 1 is equal to sine squared theta plus cos squared theta, we divide by cos squared theta on both sides. Then we get 1 over sine squared theta is equal to sine squared by cos squared theta plus 1. We know 1 over cos theta is secant theta and sine theta by cos theta is tan theta. Hence, secant squared theta is equal to 1 plus tan squared theta, or secant squared theta minus tan squared theta is 1. The third important identity is cosecant squared theta minus cot squared theta is equal to 1. Proof. Similarly, we will start with 1 is equal to sine squared theta plus cos squared theta. Now, instead of dividing it by cos squared theta, we are going to divide it by sine squared theta. So, when you divide it by sine squared theta, we get 1 over sine squared theta is equal to 1 plus cos squared by sine squared theta. But we already know that 1 over sine theta is equal to cosecant theta, and cos theta by sine theta is cotangent theta or cot theta. Therefore, we can write comfortably as cosecant squared theta is equal to 1 plus cot squared theta, or cosecant squared theta minus cot squared theta is equal to 1. Series solution. The purpose of this slide is to show that we can write sine and cosine of x, and therefore every other trigonometric function, as a series solution, because reducing mathematical complexities at some places during solving a mathematical model, we might need a series solution. So sine x can be written as x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial up to a larger value of n. N tends to infinity. In other words, you want to write it as a small quick formula. You can also write it as summation n is equal to 0 up to infinity minus 1 raised to the power of n x raised to the power of 2n plus 1 divided by 2n plus 1 factorial. You can also write cos x similarly, but with a slight modification. So cos x is equal to 1 minus x squared by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial going up to infinity. And the simple direct equation would be sigma n tends to 0, n starts from 0 to infinity minus 1 to the power of n x power 2n divided by 2n plus 2n factorial. Sine formula. This relates the angle and sides of a triangle through sine function. This is one of the formula where we can find other angles and sides. So a divided by sine a is equal to b divided by sine b is equal to c by sine c. So if you know one of them or two of them, you can find the others, or at least find the relationship of the others. Proof. The area of any triangle can be written as 1/2 of its base times height. Depending on which side one chooses to be the base, the area can be written as area is equal to 1/2 b times c sine a, or is equal to 1/2 c times a sine b, or is equal to 1/2 a times b sine c. Now dividing by ABC by 2, we will have 2 area by ABC on the left hand side equaling to sine A by A, which is in turn equal to sine B by B, and again which is equal to sine C by C. Cosine formula. Cosine formula relates the angle and length of sides of a triangle through a cosine function. The formula is a squared is equal to b squared plus c squared minus 2bc cos a. The small a's and b's are the sides. The figure is given in the bottom right hand side. So AB forms the base and BC is one side and AC is the other side. The small a is the length of BC and small b is the length of AC. The larger length AB is denoted by small c. As you can see, the angle B, capital B, and the angle A can help us write the side C in terms of two parts. How do you get the two parts? It is by drawing a perpendicular angle from the base running through the angle C, capital C. So the small side C actually can be written as two lengths small a cos B and small b cos A. So let's go to the proof. In the figure, we can actually see or derive C is equal to A times small a times cos B, B is the angle, plus B times small b times cos A, A being the angle. Now multiply throughout by C, then we'll have C squared is equal to AC times cos B plus BC times cos A. We can actually do the same thing with any of the sides, so that we can write A squared as AB cos C plus AC cos B, or B squared as AB cos C and plus BC cos A. Adding B squared, C squared and subtracting A squared, we will have B squared plus C squared minus A squared is equal to 2 BC cos A, or A squared is equal to B squared plus C squared minus 2 BC cos A. Euler's formula. Euler's formula provides a powerful connection between complex analysis and trigonometry, and it provides an interpretation of the sine and cosine functions as weighted sums. It gives both exponential delay and exponential blow. Sine A can be written as e to the power of ia minus e to the power of minus ia divided by 2i, and cos A can be written as e to the power of ia plus e to the power of minus ia by 2. If you would add cos A, multiply it with and add it with sine A multiplied with I, then we can see that e to the power of ia will give us cos A plus I sin A, and this is the same formula that we used in the complex analysis. Angle transformation formulae. Cos of A plus or minus B, A and B being angles, we can write it as cos A times cos B minus or plus sin A and sin B. Sin A similarly can be written of two angles. Sin of A plus or minus B can be written as sin A times cosine B plus or minus sin B cosine A. So we are going to see how we can derive that formula. We know that e power I theta is cos theta plus I sin theta. Now instead of theta, let us put A plus B. So we will get e power A plus B is cos times A plus B plus I sin times A plus B. Let's use the property of exponential functions. We know e power of A plus B can be written as e power of IA times e power of IB, and so therefore we can write cos times A plus I sin A as one term, which is completely multiplied by another term, cos B plus I sin B. Therefore we can multiply these two like a complex analysis function, which will lead to cos A cos B minus sin A sin B plus I times sin A cos B plus sin B cos A. Hence we have cos A plus B plus I sin A plus B equaling to cos A cos B minus sin A sin B plus I times sin A cos B plus sin B cos A. So we can compare the real and imaginary parts of both sides. Then we will get sin A plus B equaling to sin A cos B plus cos A sin B. Cos A plus B is equal to cos A cos B minus sin A sin B. Similarly, if you put in the first equation, instead of A plus B, if we put A minus B, then we are going to get sin of A minus B equal to sin A cos B minus cos A sin B, and cos of A minus B is equal to cos A cos B plus sin A sin B. So in general we can always say that sine of A plus or minus B will always be equal to sine times cos of A and B plus or minus cos times A into sin B. So you can quickly remember this. Sine of angles will always give the same sign, right? So A plus B will give the two terms getting added, A plus B. On the other side, the two terms sin A cos B plus cos A sin B. If it was sine of A minus B, it's going to give sin A cos B minus cos A sin B. And the other thing we have to remember about any sine function is always it will come with a cos function. So the product will have both cos and sine. If you see for the cos A minus B, A plus B, we'll see that is equivalent to cos A cos B minus sin A sin B. And you can see that a cos function always have two cos terms on one side, the sine terms are separate, and it is inverse of the sine. So if it was cos of A plus B, then these two terms are subtracted, cos A cos B minus sin A sin B. If it was cos of A minus B, then it is completely different. Then it's cos A cos B plus sin A sin B. Continuing the angle transformation formula, tan of A plus or minus B is equal to tan A plus or minus B on the numerator divided by 1 minus or plus tan A tan B, and we will see how to prove it for also cot A plus or minus B. Now the tan A can always be written as cos by sine by cos, so you can always treat A plus or minus B as any angle theta. We already know what sine of any angle theta means, and so we can write A plus B and divided by cos A plus B as given here. Now what we can do is, after writing it, we can divide the numerator and denominator by cos A cos B. So then what we are left with is tan A plus or minus B is equal to sin A by cos A plus or minus sin B by cos B divided by 1 minus or plus sin A by cos A sin B by cos B. You know tan A is always sin by cos, so we can replace it. Then you will get tan A plus or minus tan B divided by 1 minus or plus tan A tan B. Similarly, we will get for cot A plus or minus B will be equal to cos A cos B minus or plus sin A sin B divided by sin A cos B plus or minus cos A sin B. Now dividing numerator and denominator by sin A sin B, we have cot A plus or minus B equal to cot A cot B minus or plus 1 divided by cot B plus or minus cot A. Calculus of trigonometric functions. A curve has a normal and tangent vector at any point. Derivative of the point to the curve is given by its tangent. So you can see the curve on the right side. So there is any curve, random curve, and the tangent is the one which is very close to the surface and is perpendicular to the normal vector drawn at the point on the surface, at the same point on the surface. Any vector can be decomposed along the normal and tangent vector at the point. Linear and angular measurement. Linear measurements are measured along a line or a curve, that is length. So the unit of measurement in SI unit is meter. Angular measurement is done measuring the angle and not along the line. This is a small difference between angular and the linear measurement. The plane angle is measured in radians and solid angle is in steradians. Solid angle is the ratio of the area subtended and the square of its distance from the vertex. whereas a planar angle is the ratio of the arc to the distance from the vertex. In the case of a sphere, surface area is 4 pi r squared and the distance from the vertex is r. Hence, the solid angle is 4 pi r squared divided by r squared leads to 4 pi. Angular measurement in 2D is measured in degree and radians. The relation between them is given by theta d is equal to theta r into 180 by 2 pi, where theta d is the angle measured in degree and theta r is the angle measured in radians. So, this is the formula for converting radians to angles. For a triangle, there are 3 sides and 3 angles which describes it. In a right angle triangle, one of the angle is 90 degree. Hence, the 3 sides can be used to completely describe the triangle. The ratio of sides of a triangle is called trigonometric functions. There are 6 permutations of the 3 sides in the ratio of 2 sides at a given time. In the figure ABC are the angles where AB, BC and AC are the sides of the triangles. AB represents the hypotenuse and it is opposite to the right angle. That means it is directly in front of the right angle. BC is opposite to the angle A and AC is adjacent to the angle A. Now, describing the different ratio as inverse trigonometric functions. Inverse trigonometric functions are the inverse functions of the trigonometric functions. Specifically, they are the inverses of the sine, cosine, tangent, cotangent, secant and cosecant functions. They are used to obtain any angle or an angle from any of the angles trigonometric ratios. So, if the side small a, small b, small c are the sides of the triangle as shown in the figure on the right hand bottom, then a by c is equal to sine theta, then theta is equal to sine inverse of a over c, that is theta is the inverse of sine a by c, where theta is in radians. This you have to remember this very carefully because many people consider it to be in angles. No, theta now is in radians. Similarly, theta is equal to cos inverse b by c, or theta is equal to tan inverse a by b, or theta is equal to secant inverse c by b, or theta is equal to cot inverse b by a, or theta is equal to cosecant inverse c by a. You can see the figure on the left bottom, ABC triangle, which is a right angle triangle. Sine A, okay, is equal to opposite side by hypotenuse, which is the side opposite to the angle A is B and C. So, that becomes the opposite side, the vertical wall. So, that is BC divided by AB, which is the hypotenuse. The cos A of the angle is going to be adjacent side to the angle, which means one of the sides should touch the angle, and that is AC divided by hypotenuse AB. The tangent of the angle A is just going to be opposite side divided by adjacent side, and so that is going to be BC divided by AC. Cosecant A or cosec A is hypotenuse divided by opposite sides. It's just the inverse of sine A. So, it becomes AB by BC. And secant A is hypotenuse by adjacent. So, again AB by AC. Cot A or cotangent A is again the inverse of tangent A. So, therefore, it is adjacent divided by opposite, which is AC by BC. Looking at some solved examples for trigonometry. The question 1 is solve for x in the following equation: 3 tan squared x minus 1 is equal to 0. The solution, there are infinite number of solutions to this problem. 3 tan squared x is equal to 1, then tan x is equal to plus or minus 1 by root of 3. If we restrict the domain of the tangent function between minus pi by 2 to pi by 2, that is minus 90 to 90, we can use the inverse tangent function to solve for x as x is equal to tan inverse of 1 by root 3 is equal to 30 degree, or it is pi by 6 in terms of radians. So the solutions are x is equal to pi by 6 plus or minus n pi, which means you add pi by 6 to pi, or you can add it to 2 pi, or you can add it to 3 pi, then all those angles, the tan x of all those angles is either going to be 1 over root 3 or it is going to be minus 1 over root 3. So all those angles are all solutions of this problem. Best way to write the solution is the angle x can be written as pi by 6 plus or minus n times pi, where pi can be any integer 0, 1, 2, 3 up to infinity. And the second solution is x is equal to minus pi by 6 plus or minus n pi. That is also the solution for this problem. Trying to find the height h1 and h2. Given this figure on the right hand side, where the observer is standing at a point origin 300 meters from h1 and h2, and he can see the height h1 at an angle of 25 degrees, and the total h1 plus h2 is able to see at an angle of 60 degrees. Now if we form a right angle triangle, we can write tan 25 is h1 by 300, then we can write tan 60 is equal to h1 plus h2 divided by 300. Then when we solve for these two equations, then we can write h2 as 300 times tan of 60 minus tan 25. We are going to see the last example. The question is, if 3 times cos squared a plus 7 sin squared a is 4, the sum is 4, find the value of cot a given that a is an acute angle. Now let's look into the solution. 3 cos squared a plus 7 sin squared a is equal to 4. The first identity that we studied is cos squared plus sin squared is equal to 1. So let us try to use that. So 7 sin squared can be written as 3 sin squared plus 4 sin squared a. So 3 cos squared a plus 3 sin squared a will give rise to 3. So that is 3 plus 4 sin squared a is equal to 4. So 3, we can take it to the other side of the equation. So it becomes 4 sin squared a is equal to 1. So giving rise to sin squared a is equal to 1 by 4 and sin a is equal to 1 by 2. Why do we write 1 by 2? Because we have said that it is an acute angle. Acute means it is lesser than or equal to 90 degree. Now if we write sin a is equal to minus 1 by 2, then it is going to be more than 90 degree angle. So the value we know is sin 30 is half, therefore a angle should be 30 degrees, and therefore cot of 30 degrees is equal to root of 3. That's our final answer. Calculus of trigonometric functions. Derivative of sine and cos is given by d over dx of sin x is equal to cos x. D by dx of cos x is equal to minus of sin x. So let us see how we can come to this logically. So the red sinusoidal wave is the red color sinusoidal wave represents the sine of theta, and if you can notice from the figure, only the red curve at the x value of theta at x is equal to 0 or theta is equal to 0, you can see the value of the function is 0. But what you should also notice is the curve is tending to increase, right? Because any point after that it is having an increased slope. So that means the value is 0, but the slope is maximum at theta is equal to 0. Now if you move along the red path, then it reaches the peak. Now once it reaches the peak, it started turning. Now the theta value at this point is pi by 2 in terms of radians, or it is 90 degree in terms of degrees. Now when it starts turning, then the slope or the tangent at a flat region is equal to be a parallel to the region theta. So it becomes slope is equal to 0. But let us go to the blue wave, which is the cos theta. In the blue curve, at theta is equal to 0, the function has a value of 1, and then it's slow, but the value starts to decrease, right? So the slope is negative. 1 at the theta is equal to 90 degree or pi by 2 radians. Here we are only talking about in terms of radians. When it is theta is equal to pi by 2 or 90 degrees, you can see the value of the blue curve has come to 0. So the trend of cosine is negative, and that is why d by dx of cos theta is equal to minus, but it follows the same pattern as sine, so then it becomes sin x. Whereas for sin x, when you differentiate, it is a positive cos x. Now coming to the summary, what have we read or studied in this lecture is we have studied trigonometry, which is a study of triangles to its measures and angles and sides. It has a great utility in geometric measurement in day-to-day life. How? It represents different ratio of sides as trigonometric functions and uses relation based geometry to measure the angles and vice versa. Why it is useful? It is useful because it gives complete information of the triangles based on very few information. It gives meaning to calculus as dot and cross product of vectors and tensors are related only through these trigonometric functions. It helps in getting normal and tangential component of a vector or tensor.